Today's class is on space truss. Now, first of all, let us see what do you mean by a truss. Truss is a two-dimensional element. Now, like beam column, truss is also a structural element. It is a one-dimensional element where it is subjected to only two forces. One, the tension, and the other, the compression. Now let us see what is the space truss. Now we have got two types of truss, 2D truss and 3D truss. Two dimensional is either it can move in the x direction or in the y direction. Whereas a 3D truss, it can move in all the three directions, fx, fy and fez. Now let us see what you mean by a space truss. Space truss are three-dimensional trusses with longitudinal members connected at their ends by hinges. That is, all the joints are hinges. The joints are assumed to be frictionless, and the loads on the space are applied only at the nodes or at the joints. So this is the assumption for the analysis of the truss. Now, what is the basic concept of this truss, space truss? Now, let us see, okay, whether it is a determinate structure or an indeterminate structure. Now, determinate structure is the one where the unknown forces can be resolved using the equilibrium equations, whereas indeterminate structures, you need an other than the equilibrium equation, you need any other equations like your compatibility equations to solve the unknown forces. Now here the unknown, here the space truss is an unknown for is a 3D truss. Okay, the space truss is a 3D truss and it is an indeterminate structure. So other than the equilibrium equation, it needs the displacement equations also to solve this, to solve the member forces. Now, as a result of the analysis, what do we get? Okay, from this space truss. From the space truss, okay, we get the member forces. Now, these member forces can be resolved using the tension coefficient method. Okay. Now, before that, we will go in for